All right, guys, we're going to wrap up Unit 1 with talking about compositions of functions. So hopefully this is something that you saw in Algebra 2. So hopefully this is just a little bit of review. So composition of functions. So that's when you take one function and you plug it into another function. So a couple ways that you might see that. First one would be something like this. This is composition notation. So you might see like that. It looks like fog, but it's kind of like a small open circle. Typically, we'll use more of this notation. So like f of g of x, or obviously you could switch that around. Okay, but those notations mean the same thing. So the domain of the composite function is the domain of g, such that g of x is in the domain of f. Okay, so we're just going to talk about like when you plug one function into another function, that there could be domain restrictions on that. Okay, kind of like what we talked about the other day. If there's something that makes a function undefined at any point, we have to think about that. Okay, so I know these go a little bit out of order. We kind of rearrange some things from last year. So this starts with example 6. So off to the side, you have two functions. So there's an f function and then there's a g function, okay? So given both of those functions, evaluate the function, okay? So this first one is that first way to write a composition. So I like rewriting this. So this is the same as f of g of 3. Okay, that's what this is asking us to do. So if you have a number in there instead of just x, we always want to do the inside first. Okay, so evaluate the inside function first. So in this case, we want to find g of 3. So that means go to your g function, and then anywhere you see an x, we're going to plug in a 3. So I'm going to do that first. That'd be 3 plus 1, which is just 4. Okay, and then you can think about this as writing like a really big 4 over that g of 3. So if we know g of 3 is 4, now we're going to take that answer and plug it into the outside function. So now we're actually finding f of 4. So we'll do that second. So the f function, that's your absolute value. So absolute value of negative 2 times 4. So that's absolute value of negative 8. Absolute value means make it positive, so your answer at the end is just 8. Okay, so how about the sub? If you can pause the video for maybe just 1 minute. You guys try B, so g of f of negative 5, and then we can hit play and check it. All right, so let's check that one. So just in terms of rewriting this, outside number stays on the outside, or outside letter stays on the outside. So that's g of f of negative 5. So we want to do the inside function first. So we want to find f of negative 5. So that f function is the absolute value function. So this is absolute value of negative 10, which is just 10. But that's just the inside function. So now we want to find g of 10. So now if we do g of 10, we're going to the g function, which is just x plus 1. So we're just doing 10 plus 1. So final answer is 11. All right. So that's just evaluating with a number in there. Okay. So do the inside function first. Use that answer for the outside function. All right, so what happens if it's not a number inside? You still have an x. Okay, this is where you're actually plugging like a whole function into another function. All right, so again, let's rewrite this. So this is f of g of x. Okay, so yes, you do the inside first, but like g of x, there's not really anything to do there. So I am going to take this g of x and just write what my function is. So g of x is x squared minus 4. Okay, then I'm going to leave that f function on the outside. So this says find f of x squared minus 4. Okay, which again means take x squared minus 4 and plug that in to the f function. So I'm going to plug that in right there for x. So anywhere you see an x, replace it with x squared minus 4. Okay, so really this becomes x squared minus 4 plus 7. Okay, you see that you're just plugging x squared minus 4 in just for x, plugging that whole g function into the f function. After that, it's just clean it up, right? So yes, I put parentheses there, don't really need them. Just combine your like terms. So this is x squared plus 3. Okay, this also says state its domain. So I know we don't have a graph, so this is what we talked about the other day. You have to think about, does that function have any spots where it would be undefined? Is there anything that makes it impossible? So we said that the two things would be if you have a square root, can't have a negative in a square root. I don't have any square roots in here. And then do you have a fraction? Because you can never divide by 0. So I don't have either of those things happening here. So this one really has no restrictions on it. If you think about that, it's actually a parabola that just goes up forever. So it goes left and right. So if there's no restrictions, then your domain is just negative infinity to infinity. Okay, there's nothing that would break it. Okay, so let's try another one. You know, this can be a little tricky. So this one is g of f of x. Okay, so I'm going to take my f function and just plug it in. So my f function is x plus 7. So I want to find g of x plus 7. So go to my g function, and anywhere I see an x, I'm going to plug in an x plus 7. So it's x plus 7 squared minus 4. Okay, so yes, now we just need to clean that up. Okay, do not make this mistake. This is not x squared plus 49. It's x plus 7 times another x plus 7. And then, yes, there's a minus 4. But you have to distribute on both sides. So x times x is x squared plus 7x. Oops, that was a weird x. Plus 7x plus 49. So it's x squared plus 14x plus 49. Not x squared plus 49. Okay, then yes, there's that minus 4 from up above. So x squared plus 14x plus 45. Okay, again, now think about, is there anything that would break this? Is there a square root or is there a fraction? The answer is no, so there's no restrictions. So your domain would just be negative infinity to infinity. Okay. All right, let's scroll down just a couple more. Again, just a couple different types of functions. Okay, so example 2, this is a little out of order. Example 2, you have 3 minus x and x over x plus 1. All right, so let's do f of g of x. So I'm just going to rewrite my g function. So that's x over x plus 1. And I want to find f of that function. So I'm going to plug all of this in to my f function. Didn't really leave a whole lot of room on this one. So my f function would be 3 minus, now instead of x, I'm going to rewrite that whole fraction. Okay, that's my answer. I can't really do anything else with that. Now the second part is the domain. Okay, now this one does have an issue with it, right? It's that bottom part of the fraction. You can never divide by 0, so we're thinking, what makes the bottom 0? Well, that would be negative 1. So it's all real numbers except for negative 1. So remember how we write that? It's negative infinity to 1. I can't use 1, so I'll use a parenthesis. And then again, 1 to infinity. So that's all real numbers except for 1. Okay, so why don't you guys, if the sub, again, could please pause the video right now. You guys try B and then maybe come back. Let's do 2 minutes on this one. 2 minutes, and then we'll come back and check it. All right, so this is g of f of x. So the f function is 3 minus x. So we want g of 3 minus x. Okay, so when we go to rewrite that, that's, okay, have an x on top, so it's 3 minus x on top. And then it's x, so 3 minus x plus 1 on the bottom, right? This is everything I put in parentheses I'm replacing from the x. Okay, now this does have some like terms, so 3 minus x on top, and then it's 3 plus 1, so that's, that's 4 minus x, or you could say negative x plus 4. Either way would be fine. Okay, so now this one, when I think about the domain, I don't care about the top. You can do 0 divided by anything all day long. That's just 0, which is fine. That's a number. It's just the bottom. So I need the bottom to not be 0, right? Well, you're thinking, what makes that 0? Well, you could go through and solve this, or you could say, well, it just has to be 4, right? Divided by negative 1. So x cannot be 4. Okay, so again, it's negative infinity to 4, can't be 4, so I'm going to use a parenthesis, and then 4 to infinity. All right, so hopefully that one went okay. Last example, again, just different type of function. So this one I have f of g of x. I'll rewrite the inside, so g of x is x squared, so I want f of x squared. Plug in x squared anywhere you see an x in the f function. So that would be the square root of x squared plus 5. Okay. Last one, g of f of x. Rewrite f. That's the square root of x plus 5. So plug that into the g function. Ooh, this one is a little interesting. So where you have an x, we'll plug in square root of x plus 5. So it's that squared. Well, what happens when you have square root and a square? They cancel out. So this is really just x plus 5. Okay. So if timing is working out, when you guys get back from lunch, there is a 1.7 lesson check that you can work on in your groups. Okay, so that will be open when you come back from lunch, and then you can spend the rest of the period working on any missing lesson checks. Or if you have any that you just don't like the score that you have and you still have an attempt on it, go back and fix that up, okay? So just a reminder, I showed you guys this the other day. So you practiced 1.6 already, you got your video, now you're gonna have your lesson check. So tomorrow, again, you'll have a review, and then I'll be back on Monday and we'll actually physically go through everything. But do the review you get tomorrow, so you come in with questions on Monday and we have some stuff to work with. Okay? All right, guys. Thank you so much.